Hello everyone, welcome back to Project Java. My name is Venkat and today I'll take you on a tour to modules in JDK 9. This is very important feature when it comes to encapsulation, one of the fundamental object-oriented programming principles that you learn in junior classes. How is it implemented? Is it just about four access specifiers? Well, we'll learn about this in this video. So let's begin. We start with the question that is encapsulation enough, which definitely isn't. So let's discuss the agenda of modules. We'll start with the introduction, the custom modules, hierarchy, and then we'll summarize the entire video. So, what are modules? Are they normal packages that Java has changed the name of? No, it's not that case. It is different. In what way? Let's see. It is a set of exported and concealed packages designed for reuse. It lets you reuse specific parts of your project. But why is it used? It is because it offers scalability over normal packages and it offers strong encapsulation. What do you mean by strong encapsulation? We'll learn about that right in the next slide when we talk about access control. Here is a comparison between modules and packages prior to JDK 9 and after JDK 9. So we'll get to know about what are the different access layers that are being brought to us by the introduction of modules in JDK 9. Modules definitely offer a strong encapsulation and access control because prior to JDK 9, with the use of packages, you would have only four access specifiers: public, private, protected, and package private, which in common terms you called as a default access specifier. Now, what modules bring with it is that a package can be public to anyone. It can be public, but only to specific modules. It's like using protected keyword for packages, then public only within one module in which you would want, which also means a concealed package, and the rest of the access specifiers protected, package, private, and of course public. So these are the access control that you get to see that modules bring with them. Let's move on to the next slide. What are reliable dependencies? Well, with this, it means that you can both import and export packages from one module to the other. Interesting, right? How would you do that without modules? That means, how would you do that prior to JDK 9? Well, if you had a project A and if you wanted that project A to be accessible in project B, you would have to create a jar, you would have to export project A, and then you'll have to import project A in project B in order to use the classes that are there in that project. Strange. That's just the only way that you go about distribution of code. But with the introduction of modules, you can import and export packages from one modules to another with a little easy way. But there is no option for concealed packages within the modules to be accessed by other modules. These are the exact same packages which you won't want to be discoverable to other modules. It's like making it module private, not package private. So it can be accessed within the same module, but not in other modules. Now what does this do? This helps segmentate and allows reusability of selective classes and packages. It offers strong encapsulation in the way that you could specify which modules would have access to a particular module and which modules would have access to what packages within that module. So that is what we mean by strong encapsulation. Let's move on to the next slide. Here are some module related keywords that you should keep in mind because, well, JDK 9 worked upon it. And here is something really important that you will need to make your project modular. Starting with the first one, export package. Pretty simple. It declares which package is eligible to be read by other modules. For example, I have a module A and I have two other modules B and C. So we have a package in module A, let's say XYZ package. So basically, we want that this XYZ package should be present and should be present for using purposes in package B as well. So what we do is we first export this package from module A. We declare that, we want to export the package XYZ to all the other modules. In fact, we just want to make this XYZ package public throughout the modules present out there. And within this B, you would add a dependency of module A, which will help you access this XYZ package which module A exports. So this is what export package does. Now this one, export package to a specific module. This declares that package is eligible to be read by a specific module only. Let's say I want XYZ to be only accessible to B module B and not module C. So in that case, I can declare that you should export package XYZ to module B only. Then another very important keyword which is requires module. It says that it specifies the dependency of the other module so that all the packages within it declared to be accessed by this particular module B. Let's say I have this module B and it wants to access package XYZ. So basically, there'll be a dependency of module A. So in order to fulfill that dependency, you need to use requires keyword with the module that you want that you require, or with the module on which your program or your project is dependent. So if I want to access package A, I write requires module A. And then there is the requires transitive module, which is definitely it specifies another module to read from where the relationship is transitive and indirect. Access is given to the modules requiring the current module. We'll discuss about this in some other video because it is a totally different thing and you won't really need that much of it. But what are the what are the facts that we need to know about this? That these are restricted keywords and they are only be allowed to use in the context of module info class. Yeah, that is true. Let's know about this. How to implement modules. Now let's jump back to IntelliJ in order to see our project. So here is our IntelliJ and we have two modules, module A and module B. Let's say what we want to do is we want to have a class in module B which would be accessible to module A and it would print and the class in present in module B would print something. Let's see. So we have a package, namely package 2, and within package 2 we have pack2.class. What this does is simply has a static method print pack2 which would print this particular message printing package 2. That's it. And we have the module info for this particular module, which is module B. What we do here is we export package 2 to module A. This means that we want package 2 to be specifically available to module A only. And that is how we are going to use this pack2 class in module A. So here is our module info for module A. We require like this particular module A requires module B. Don't think about this requires java.base, we'll explain this. This is basically irrelevant to, right? You can also ignore it. So it requires module B. This statement states that all the packages that are declared to be accessible by module B, that is like package 2, can be accessed now after you add a dependency of module B here. And now once we see package1.class, we simply in the main method we call pack2 class.print pack2. And let's see, let's execute this code. Pretty nervous, I'm trying this for the first time. And there we go. We see printing package 2. So this is how modules can be implemented in your project in order to make it scalable. Let's return back to the presentation. So what's a module based on? It's based on a software engineering principle which says the unit of reuse is the unit of release. Java follows this. Whatever be the case, whatever be the scenario, definitely the unit of release is a jar file, or we know that as Java archives file. But JDK 9 says that this jar file can be modified into modular jar, which would contain both module files and the class files. What is the use? Well, basically, all the packages within a module can be tightly coupled, another software engineering principle. And modules in general provide loose coupling in between of each other. So that is the benefit. But you might have a question that, if you build a modular app, what do you think you get? What are the benefits? Well, if your code resolves at the compile time in a modular application, you would have no missing dependencies, which means if a project B requires some modules from project A, there won't be any missing dependencies because it would be checked at compile time for those dependencies itself on the fly. There are no cyclic dependency, which means that if I have a module A and I have a module B, and in both of these modules, if I say that module A requires module B and module B requires module A, there is this particular scenario is called a cyclic dependency, which is strictly prohibited in module systems, modular apps. Then there is no split packages. So this is another issue that you would find. How exactly split packages affect your class path? Let's see. For example, let's say that I have a package, a common package ABC in three jar files, jar 1, jar 2, and jar 3. Okay, let me just name this 1, 2, and 3. So this package ABC is common in all of these jar files. And let's say I have a project, okay, I have a project which has a dependency of all these jar files. So what happens if prior to JDK 9 you try to build this particular project, let's say project A, if you build this project A with the use of class path, what you will see is there might be some number of classes which are taken from this particular package ABC from jar 1, whereas some number of classes would be taken from jar 2 ABC package and some number of classes from jar 3. What this does is it confuses between what classes, what packages the project requires. If there are three dependencies like this jar files, and there is one common package, then there are chances that classes, so some classes from jar 1, some classes from jar 2, and some classes from jar 3, your project will pretty much be fucked up. And this is what is prevented when you are building a modular application. With the introduction of JDK 9 modules, there specifically needs to be mentioned which package is to be required by which module and which package should be exported to which specific module in the code. But again, you might think that, I mean, that is what Maven does. It might be a question. Maven is a building, like it's used for building your project. It eases that development process. But let me say, Maven is only available at compile time. Modules are available only also at compile time and at runtime as well. So this is the benefit that you get with modular programming in Java. Now let us learn about some platform modules before we end up this video. What are they? Before looking at this picture, I'd want to say that this particular arrow means or is equivalent to the requires keyword that we have. I talked about this requires keyword while I was implementing the module, so you can rewind the video if you want to check that section. So starting at the very top, we have Java SE, which requires Java SQL row set, requires XML crypto, Java management RMI, Java security JDSs, Java preferences, and Java management RMI requires Java management and Java RMI, which is remote method invocation. We'll talk about this in some other video. It requires Java instrument, it requires Java compiler, requires Java desktop. Then again, Java desktop requires Java data transfer, Java XML, Java SQL row set requires SQL, which requires logging and XML as well. SQL row set requires Java naming, and all of these modules are required by Java base. So, what Java people have done is they have made this java.base module accessible to all custom modules and all user defined modules by default. So that's pretty cool because Java base has a set of important packages like the Java util package. Then there are other packages like java.lang, java.math, and all of those which are required by any application. So whether you use modules in your project or whether not, java.base is the default module which is required by all the other modules in your project. With this, we summarize our video. Thank you for watching. Hope you learned a lot. And if you like this video, please like, subscribe, and share our channel so that we can reach out to a huge crowd and they can also learn from these kind of videos. It really helps us keep our motivation and the streak of creating videos as well. This is Venkat signing off from this video. Thank you.